In the Module 1, Section 5 practice, we're going to take a look at absolute value inequalities. So similar to an absolute value equation, an absolute value inequality always has two inequalities you need to solve. The inequality that you start off with determines what type of compound inequality you have to solve. So if your original absolute value inequality is less than or equal to, your solutions are written as an and compound inequality. So that means one interval. If your original absolute value inequality is greater than or equal to, your solutions are written as an or compound inequality, which means two intervals. When you solve an absolute value inequality, that second inequality, not only do you flip the sign of the number, you also flip the inequality. So let's take a look at our first example. We have the absolute value of x is less than 9. So similar to an absolute value equation, our first inequality is going to be solved by just dropping the absolute value. So x can be less than 9. When we set up our second solution, we have to flip the inequality, so x greater than, and then we flip the sign, so negative 9. So now I have to determine, am I writing my solution for my interval as a single inequality or as two? So if I look back up, it's kind of like my cheat above. If my original absolute value inequality was a less than, we write it as an and compound inequality. So this means one interval. So if I look, x has to be less than 9 and x has to be greater than negative 9. So when I write my interval, the left side is going to be negative 9 because that's the value I'm greater than, and it's the smaller of the two. And my right side is going to be 9 because that's the bigger value and that's the value I have to be less than. Now in this case, both values should have either both parentheses or both brackets. They should always match here. And because we were strictly less than, we're going to have parentheses with both of our values. Okay. Our second example is the absolute value of x minus 6 is greater than or equal to 1. So the first inequality I want to solve is x minus 6 is greater than or equal to 1. Solve that inequality, we're going to add 6 to both sides, so we get x is greater than or equal to 7. So our second inequality, we start off with x less than 6, then we're going to flip the inequality, so less than or equal to, and we're going to flip the sign of our number, negative 1. I'm going to solve this inequality the exact same way I solved it the first time. I'm going to add 6 to both sides. And we end up with x is less than or equal to 5. So if I'm trying to determine if this is an or or an and, again, looking up to my cheat above, my original inequality was greater than or equal to. So that means that we're going to have an or solution. So or means you write two intervals, and you always start with the interval that contains the less than. So everything less than or equal to 5 is going to be parenthesis negative infinity comma 5 with the bracket because it's got an equal to. Union, now everything greater than or equal to 7, we have a bracket with the 7 comma infinity with a parenthesis. Now with the absolute value inequalities that are or, you will have parentheses because you're going to have a negative infinity or an infinity, but if I look, the numbers, they still match. They both have brackets. So anytime you're writing an interval notation for the solution to an absolute value inequality, the number should always either have both parentheses or both brackets. So our next example is the absolute value of 2x minus 1 is less than or equal to 17. So first inequality I want to solve, 2x minus 1 is less than or equal to 17. First step is going to be add 1 to both sides. So we get 2x is less than or equal to 18. Then we're going to divide both sides by 2, and we get that x is less than or equal to 9. Second inequality, we're going to set it up as 2x minus 1 greater than or equal to negative 17. The steps to solve are exactly the same. I'm going to add 1 to both sides. We're going to get 2x is greater than or equal to negative 16. Divide both sides by 2, and we get that x is greater than or equal to negative 8. So we've already done an example of a less than. We did that first example right above us, so we know that the solution is written as and when we're writing our interval for and, the smaller number goes on the left, so negative 8, the bigger number goes on the right, 9, and because our inequalities had equal to's, we put brackets with both of the values. So as long as I pick a number that's greater than or equal to negative 8 and less than or equal to 9, it is a solution to my absolute value inequality. Our very last example says the absolute value of 3x minus 7 minus 4 is greater than 2. Now, just like an absolute value equation where we had to isolate the absolute value before we can solve, we have to do the exact same thing with an absolute value inequality. So before I can actually set up my two cases for my absolute value inequality, I have to isolate it. So that means adding 4 to both sides. So we're actually looking at the absolute value of 3x minus 7 is greater than 6. That's the inequality I'm going to use to solve, to set up my two cases. So my first case, 3x minus 7 is greater than 6. So we're going to add 7 to both sides, so we get 3x is greater than 13. Then we're going to divide both sides by 3, and we get x is greater than 13 thirds. Since 13 divided by 3 is not a whole number, and I do not like using decimals for inequalities. So the second inequality we want to solve, we're going to do 3x minus 7. We're going to flip the inequality, so less than, and we're going to flip the sign of my number, so negative 6. So we're going to still add 7 to both sides, so we get 3x is less than 1. Then we're going to divide both sides by 3, and we get x is less than 1/3. So now I need to decide, am I writing two intervals or one? So we did an example directly above this that was greater than or equal to, so we know that greater than is going to be written as or. So we're going to write two intervals, and we always start with the interval that is less than. So if I'm writing everything less than 1/3, we're going to do parenthesis negative infinity, comma 1/3, and because I'm strictly less than, I'm going to put a parenthesis, then our U for union, then again, strictly greater than for the greater than 13 thirds, so I'm going to have parenthesis 13 over 3, comma, infinity with another parenthesis. This is probably the hardest section out of Module 1 because we're combining 3 of the sections we talked about. We're combining absolute value equations with compound inequalities and interval notation. So it is extremely important that if you're struggling with any of this, whether it's the interval notation, setting up the two inequalities, or trying to figure out whether or not it's an or an and compound inequality, please reach out, please ask for more help. I'll be glad to help you.